And hello from the campus of Carnegie Mellon University in Pittsburgh, Pennsylvania. We welcome you to today's SEI webcast, how to address the problem of poorly defined requirements in software systems design. My name is Shane McGraw, the outreach team lead here at the Software Engineering Institute, and I'd like to thank you for attending. We want to make our webcast today as interactive as possible, so you can submit questions in the YouTube chat area now. We will get to as many as we can. We did receive a number of questions prior to the webcast. We will work in a few of them as well. Now I'd like to introduce our featured speakers for today. Lyndsi Hughes is a senior systems engineer in the CERT Applied Systems Group. Since joining the SEI in 2010, Lyndsi has operated and maintained numerous specialized computing environments in support of research projects, malware analysis, and software engineering. Welcome, Lyndsi.
Thanks, Shane.
Dr. Lori Flynn is a senior software security researcher, also in the Applied Systems Group here at the SEI, where he's interested in novel ways to automate software security. Her focus areas include static analysis, automated program repair, artificial intelligence, machine learning, large language models, malware analysis, paint flow analysis, and cybersecurity. Thanks for joining me today, Lori.
It's great to be here, Shane. Thanks.
Okay, Lyndsi, and I'm going to turn it over to you to start our talk.
Yeah,
thank you.
Fantastic. So I want to start off today by making maybe the most controversial statement you'll hear all day, and that is that software engineering is hard. It's difficult to engineer software that functions in exactly the right way, only as it's designed, only as it's intended, free of defect. On top of all of those challenges, we also have to deal with all of these variables that we can't control that are going to impact our software and its ability to function. The ecosystem where our software is going to run is constantly changing. As software engineers, we have to deal with hardware changes, like making sure our software can support ARM processors. We have to deal with platform changes, like making sure our software can run on virtual machines or inside a Kubernetes cluster. We have to deal with other software changes. Old libraries get deprecated, new libraries are developed, your favorite operating system releases a new version, APIs are revised and updated. There's just challenges all over this process. And so engineering quality software gets even harder. The IEEE has offered us this definition of software quality, and that is the degree to which software possesses a desired combination of attributes. So for our purposes today, we can think of attributes of our software as falling into one of two really broad categories. Those are going to be what we want the software to do and what we want the software to be. What we want the software to do is equivalent to what we might call functional requirements. And what we want the software to be is equivalent to what we might call non-functional requirements or quality attributes. Quality attributes include properties like performance, usability, security. And when we add in all of these quality attributes to our set of functional requirements, we really increase the complexity of our software dramatically. But these are all things we need to include if we actually want people to use our software. And in the same way that we should expect the ecosystem changes to impact our functional requirements, our quality attributes are impacted by external factors that are constantly changing and evolving. For example, new vulnerabilities and threats to third-party software are constantly being discovered, and software engineers have to stay up to date with this information as they develop their software. So hopefully so far, I've been successful in establishing that we need to define requirements that describe our software's functionality, and we need to define requirements that capture our software's quality attributes, and we need to be adaptable to changes. From here, I don't think it's a big leap to assert that having well-defined requirements is a key foundational piece of producing quality software. And we've already defined quality attributes broadly as what we want the software to be. So let's quickly break down a software quality attribute into parts. And there are three parts. We have concerns, which are how the software is judged, specified, and measured. And these are going to include requirements. We have attribute-specific factors. And these are properties of the system that impact the concerns. And we'll talk about more about these in a bit. And we have methods. That's how the concerns are addressed. And these include activities like requirements gathering and development practices. And we'll also be touching on these ideas in just a bit. So we're going to offer 3 strategies that can be used in conjunction with one another that can help ensure your requirements are well defined. So we're going to rely on principles from DevSecOps that are particularly helpful when working with software requirements. Having a DevSecOps mindset is going to enable us to stay adaptable to all of the changes impacting our software, both functional and quality attributes. And it's going to encourage us to pay attention to metrics that are going to go into our feedback loop and inform us as we iterate over the software development lifecycle. We're also going to talk about a strategy to analyze requirement trade-offs, specifically as they relate to quality attributes. And we're going to talk about a strategy to use math to objectively support our decision-making about our software requirements. So where do we start? We start in the planning phase of the software lifecycle. So this planning, it applies to both greenfield development and iterative development. And the principles that we're describing can take place at the very beginning of a software project or somewhere in the middle. And the strategies are, they may sound like they're referring to waterfall development specifically, but they apply equally well to an iterative development process. Right, so there's tension between different software quality attributes. So as an example, if you imagine my team is designing a web application that for security reasons employs multi-factor authentication. We're going to require a password. We're going to require a TOTP, a time-based one-time password. And we also want to require a retinal scan. Now, this would result in extremely secure logins, but we would probably eliminate a huge subset of potential users who don't happen to have retinal scanners at their house, right? So the usability of our software would be significantly impacted if we only optimized for security. So this is kind of a ridiculous example, but it drives home the idea that as we decide exactly what functionality we're going to build into the capability and how we're going to implement it, we have to consider all of these trade-offs between our functional requirements and our quality attributes. And so what's the best way to do this? Well, in our work, we're advocating for the use of the ATAM, the architecture trade-off analysis method that was developed here at the SEI a number of years ago. This formalizes a process to use for analyzing any system, in particular, the various trade-offs between functional requirements and quality attributes. The purpose of the ATAM is to assess the consequences of architectural decisions in light of quality attribute requirements. And the primary goals are to elicit, make concrete, and prioritize the driving quality attribute requirements. Now, the ATAM defines a process for doing all of this, and the process is meant to highlight the trade-offs between various design decisions, where the improvement of one quality attribute has a negative impact on another quality attribute. And the structured nature of the ATAM can help us, it helps us by providing scaffolding to compare requirements and make these decisions on how requirements should be prioritized. And so we're going to highlight a few parts of the ATAM process that we find the most helpful in making sure that your requirements are well defined. So first, let's look at a software quality attribute called security as an example. As we're gathering requirements for our software, we might say something very generic like our software must be secure. Fantastic, but what does that actually mean? Well, we have to break this idea of security into more specific parts. And on this graphic, we list out a few of those parts. This list of items is what ATAM would call sub-factors of security as a software quality attribute. Now, this certainly isn't an exhaustive list. I'm sure you can all think of many other categories of sub-factors relating to secure software, but we're going to build on this idea of sub-factors as we continue through the ATAM process. So we're going to use the sub-factors and their refinements to build a utility tree. Now, a utility tree is constructed top-down. It's top-down really in two ways. First, the utility tree is going to be assembled by the project leaders and software architects to communicate the business drivers of the software that we want to create. And the second way that it's top down is that we're going to work from the top of the tree, from less specific to the bottom of the tree, which is more specific. During our planning process, our software architects and project leaders are going to build the utility tree, and they should be refining the nodes as much as necessary to get requirements that are specific, measurable, and actionable. They should be actionable either in the ability of architects to use those requirements to design software, or actionable by developers to actually implement features of the software. Now, in the interest of space on this graphic, the example requirements here are not nearly specific enough. They would need to be refined much further to get to the point where they are measurable and actionable. The result of all this work on the utility tree is going to be a set of prioritized requirements, and Lori's going to talk more about prioritization in a little bit. So this would be a good time to pause for a couple questions. Shane, do you have any questions for us?
We do. As I mentioned at the start, we had a couple questions come in prior to the webcast. So Stephanie had asked, how will AI or LLMs impact requirement specification and analysis? How might they help us? Either one of you want to take that one?
Sure. So LLMs can help us to brainstorm parts of the utility tree and the weighted decision matrix that we'll talk about later. They can help teams to brainstorm about quality attributes, about possible sub-factors, and requirements. They can also help teams to identify tools that can be used to automatically measure the software to see if it's meeting the requirements. So that's how it can be, an LLM can be useful for the process. Now, an LLM could also pose some problems because they can hallucinate, they can be wrong. So validation of information that's output from the LLM is important if you're going to use it. But the LLMs can also be useful to help validate their output. You can ask them for references that provide verifiable information about the ideas that they provide. And in addition to brainstorming, they can help you to improve what you've developed so far.
Thank you for that, Lori. Next, we have one from Vince asking, what are some of the best ways to get end users of the system being designed to actively participate in requirements definition, test case creation, and other elements of software development? Lori or Lyndsi, want to take that one?
Yeah, I'll take that one. Because that question is a great segue into the next portion of the ATAM that we're going to highlight. And so in answering a question about LLMs, Lori mentioned the brainstorming. Well, brainstorming is a key piece of the ATAM process. The next step after building the utility tree is we want to gather as many stakeholders as we can together to brainstorm various use and operational scenarios of the software that we want to create. So Vince, this would be where we're pulling in all of those different roles who have an interest in the software's function, the software's quality, and making sure we get their input into the set of requirements that we're trying to build. All right, we're going to bring in as many stakeholders as we can in as many roles as we can, including developers, testers, users. The goals for this activity are going to be to specifically get the feedback of more stakeholders so we can be sure that all of the relevant interests are captured, and to understand the needs of the stakeholders. The process is, as displayed on the graphic here, we want to elicit as many scenarios as we can think of, various ways that we would be using the software. Then we're going to vote on how those scenarios should be prioritized, and all stakeholders do get a vote in that process. And finally, we're going to compare the prioritized scenarios with the prioritized utility tree requirements. Now, during this comparison, we want to check for agreement. We want to make sure that the ideas of the architects and the project leaders are matching the scenarios that all of our stakeholders have come up with. If we have agreement, that's fantastic. We've confirmed that our stakeholders care about the things that our system architects have identified. If we don't have agreement, we have a little bit more work to do. We may have identified some additional requirements during this scenario elicitation. There may have been things the architects, the project leaders didn't think of that need to be considered requirements for this software. We may have to remove some requirements. We may realize that our stakeholders don't actually care about something we thought was important, or that our architects and project leaders thought was important. Maybe that requirement should be removed. We also have to ensure that we don't have any irreconcilable differences between our prioritized requirements in the utility tree and the prioritized scenarios. We need to be able to explain any discrepancies there. And basically, we would iterate, again, another sort of DevSecOps idea. We iterate and keep working until we either have agreement or we can explain all of our discrepancies. So at this point, after all of this thinking and meeting and discussing, talking about our functional requirements and our quality attributes, how they're related, we should have identified and discussed all of the trade-offs that are going to impact our software design and the implementation. And in so doing, we've mitigated a number of threats to our software's quality. We should also have a set of requirements that are precisely defined, they are measurable, they're prioritized, and they're ready to hand off to our architects who will design our software, or to our developers who are going to implement the requirements. Now, I want to kind of pause here and call out at this point that we've sort of used security as an example quality attribute in our utility tree and in listing out our sub-factors, but this can be done for any quality attribute of your specific software. This isn't really a paint by numbers activity. Do this, do this, do this, right? It's a structure that helps inform your process and your decision-making. But you get to define what quality means for your software in your context and with your specific goals. If your software design requires another or a different set of quality attributes, you can still use all of these techniques to create your own custom quality attribute and create your system requirements with all of that in mind. And before I move on to the next section, can we pause for another question? Shane?
Yeah, we had one from Lowell. It was a great question. What are the red flags for bad requirements?
There are a number of them. Some of them would be you have a requirement that is not specific enough, that makes it not actionable. I'd mentioned in talking about the goals of this process, we want to make sure our requirements are measurable and precise. If you have a requirement that's not measurable, that would be bad. You'd want to go revisit that. You can also have requirements that are, there's definitely a balance to be found when defining requirements, because you don't want them to be too specific in a way that limits the way your software can be implemented, limits what your developers can actually work with. And you don't want it to be too general. You have to find the sweet spot in the middle of defining them too specifically and not specifically enough. I think one other thing that I would note would be that if your requirements are conflicting, you have one requirement that says you must do X, you have another requirement that says you must not do X, you've got a problem. You'd want to investigate that.
Just a quick question from Roy in the chat now is, how do you measure for the success for whatever you might mean of the process you're talking about? So how do you measure the success of the? Is there anything in particular you're looking for? Was he referring to the ATAM process, or how would you measure that?
So that is another great segue into the next section of the talk. So yeah, I'll just roll ahead, or would you like to add something first?
Okay, yeah, I think the whole process is targeted at making sure that your quality matches what your stakeholders are interested in. So a big measure of success is, are your stakeholders happy with how you're progressing? And we'll talk about some methods to further develop the utility tree concept to do that.
Great, thank you.
Great. Yeah, so I'll forge ahead into one method for measurement. I guess I should sort of caveat this by saying I think there are others. We're highlighting this one. So we're back looking at the software development lifecycle, the infinity diagram, and we're jumping ahead a few places from the planning to the testing. So we've completed our planning, we've done some development, we've built some software, and now it's time to test. We need to be able to determine if the software we've built is meeting our quality goals. And we want to be able to do this objectively if we can. So thinking about some of the traditional goals of software testing, right? Testing is a critical piece of modern software engineering techniques. It plays a very prominent role in DevSecOps principles and the Agile methodology. And there are some well-defined and well-understood goals of software testing. High-performing teams will inevitably use multiple types of tests throughout multiple stages of the development process. And each type of test should be increasing our confidence that the software we built is doing what we expect it to do. If we intend to deliver working software to our users, then testing is critical. So over time, we've developed new methods for testing that supplement the traditional methods. And these include several different strategies, but the one I want to highlight here is static application security testing, or SAS, which is going to come up in some of our examples later. Each type of testing is going to provide a different set of metrics. And as we iterate during software development, these metrics are going to be critical feedback for our team because they inform our strategies and activities and help us determine if our software is meeting the requirements we specified. So Shane, I think that addressed the last question, but we can pause here if there's any additional questions.
We did have another question from Carol ahead of the webcast asking, how do you see software sustainment requirements fitting in? How do you see software sustainment requirements fitting in?
So sustainability is a quality attribute. And there are many tools, many things that can measure aspects of it, and requirements can be set that can be then measured with the tools. So for instance, there are code metrics like cohesion and coupling and interface complexity. How many parameters are fed into functions or methods? How many significant lines of code per function or method? Also, how many return points in a function or method? Also, there are security related tooling, SAST, SCA, and fuzzing that Lyndsi discussed. Other types of testing that relates to sustainability metrics include test coverage, types of testing. So there are many ways that the quality attribute of sustainability can be measured.
Great, thank you for that, Lori. We can move on. Yeah.
Great, yeah. So you move on, we're still thinking about testing, and there's still many threats to our testing success, right? Just having different varied types of testing available to development teams and in use by development teams doesn't necessarily guarantee success when it comes to software engineering. There are challenges to testing that can prevent the tests from giving us accurate information. Sometimes testing tools can be inadequate. We can use incomplete testing procedures. Maybe we didn't think of everything that we needed to be able to test. We can also have testing methods that include too many manual steps. Without solid testing procedures in place, bad things can happen. We can end up with inconsistent test results that result in poor software quality. Poor software quality can prevent successful achievement of our goals. So as we're figuring out how to avoid these testing pitfalls, where should you begin? Well, remember all of the work we did to figure out all of our requirements and specifically to prioritize those requirements. We're arguing that's where you should start with your testing. You have, well, let me pause to say, we don't have any specific prescriptive advice about building a test plan because each software engineering context is going to be very different. But instead, we want to offer some abstract ideas for you to consider as you're designing tests that will test your prioritized requirements, taking into account the priority of those requirements in terms of what's the most important, what's the least important. We want you to do these three things: get automated, get objective, and get creative. Automation is going to remove some variables that would qualify as those threats to your testing success. Variables like the quality of the testing that's done, the time it takes to perform the testing. Adding automation is going to help you get consistent. Also, since we were very careful during our requirements gathering process to make sure that all of our requirements were measurable, we should be able to make tests that measure them and then give us information with metrics that say whether or not we are meeting our requirements successfully. And finally, get creative when you write tests that give you the information you need to know about your software. So as an example, my team has been developing a specialized dynamic testing tool that helps us to understand what impacts a specific program or piece of software will have on the system where it's deployed. Now, we started developing the testing framework because we looked at our testing needs and determined that the traditional types of testing were inadequate for what information we actually needed about our software. And so we had to get creative. We had to think about what do we need to know about these programs that we need to test. And we went ahead and created our own framework for performing the tests that we actually needed. So it takes an understanding of what you're intending your software to do and an understanding of how can you verify that your software is doing what you expect, and then maybe thinking outside the box to come up with some testing ideas to accomplish your software goals. And so at this point, I'd like to hand things over to Lori, who's going to talk about how we can use math to support our decisions.
Thank you, Lyndsi. So since we're trying to help people to make good decisions about their software, we chose to use weighted decision matrices to augment the utility trees. So a weighted decision matrix, or WDM, is a well-established technique for supporting decision analysis. Options that are compared using the weighted decision matrix make trade-offs, and they do better on some quality attribute factors and worse on others. So a weighted decision matrix uses criteria, in our case, requirements. They use per criteria weights, which in our case, we multiply by our metrics. And they get total weights per option. Now, where do the options come from? They are expert identified possible matches for stakeholder needs that meet the functional and non-functional or quality attribute requirements. And they involve trade-offs. They do better on some qualities, attributes, subfactors, and do worse on others in most cases. So What we're going to show you in this slide and a lot of slides after this involves a simple example matrix that we put together looking at areas of security related to scans that output alerts about possible security problems. Now, Lyndsi mentioned some of these tools while talking about modern testing, static analysis tools, which analyze code without executing it. Their typical alerts warn about CWEs or STIGs, possibly. Software composition analysis, that's SCA. Typical alerts warn about known vulnerabilities, CVEs, and secret scanning tools, which scan for API keys, encryption keys, and more. All of these alerts that are output include false positives. Historically, there's been a trade-off between cost, which funds experts to manually adjudicate and fix true positives that they find. And they trade off expense for that, effort towards that, versus the quantity of alerts adjudicated. And usually that results in many unadjudicated alerts, which then means uncertain remaining risk. Okay, so for this example utility tree with priorities that you see here, the seed scenarios include critical infrastructure software development and mission critical software development. So security is very, very important. And as you see here in the priority column, the two security subfactors, the top ones are the highest priority rated ones. So once the top security subfactor involves adjudicating alerts, meaning determining true or false positive, and the test is % adjudicated alerts. The test quality threshold requirement, minimum requirement, is that all critical and high alerts have been adjudicated. So medium and low risk alerts don't have to be for that threshold. The second security subfactor involves fixes for the critical and high alerts. So either the code has been repaired for those or a false positive adjudication was determined. The test involves checking to see if that's been repaired, automated systems that identify and track static analysis alerts can identify if there's been a commit that eliminated a static analysis alert. And similarly for the test above, that systems can track adjudicated alerts. Okay, back to the requirement for the fixes. The requirement here is that all critical and high alerts have been fixed or adjudicated false. Now, next is the cost subfactor of 1 year estimated costs. There is no threshold requirement for this, but organizations always want to minimize costs. And then finally, usability. There are many types of subfactors. In this case, we're just focusing on the code variability subfactor. This aspect of usability has to do with ease of correct setup in a system. And what's measurable for this one is flexibility of code, for instance, compile time, flags, counts. So that is the lowest priority in this example. Next, we further develop our weighted decision matrix. Those three, this is still the same example. But now we're going to talk about what are the options that are getting compared here. Well, the options are two different methods. Method 2 uses the kind of traditional method of fully manual alert adjudication and code fixes. Method 1 uses more automation. It uses LLM-assisted alert adjudication, similar to SEI's current research work on the LASA project. LASA stands for LLM-assisted static analysis alert adjudication. And method 1 also uses automated program repair, or APR, which is a technique that is used at many large development organizations. The APR tools are part of Google's tool chains and Meta's and Bloomberg's, and many big organizations use those tools. And SEI, and there's lots of active research and engineering going on in those areas. SEI has a redemption project and redemption tool that's an APR tool. For these two methods, we now consider the test results. So for the test of percent adjudication, that top blue row, method 1, more automation, it has 90% alert adjudication, whereas method 2 only has 5%. It's hard for organizations to afford experts to adjudicate a large amount of the alerts. Next, the metrics for repaired alerts. Both of the methods repair critical and high alerts. This is just a Boolean metric here. Either they do or they don't. So both meet that minimum metric, which, thinking back to the scenarios, the seed scenarios, they both were high security. It's very important to repair or determine false positive for adjudications for critical and high alerts. And then for cost, the cost for the automated system, it's less. Experts are very expensive, and manual adjudication's more expensive. For usability, for this metric of code variability, the method 1 we estimate as being slightly higher because there's a bit more involved in setting it up, although other aspects of usability make it much easier. It's easier to have something automated, just suggest a patch and an expert decide yes or no. Okay, so those are the metrics and the tools. Next, we look at how we scale the results, where the result is R. Higher is better throughout this weighted matrix. However, in some cases, a metric is worse as it gets higher. For instance, cost is worse as it gets higher, so you see that that metric is inverted. But security at the top, the more security, the better, so it is not inverted. So the second way that we scale involves making different metrics closer in value by multiplying or dividing. For example, bandwidth in bits per second, maybe an enormous number, but fraction of alerts adjudicated in our table is between 0 and 1. So that can also be part of the scaling formula. So now in this example, we multiplied the initial measurement using the scaling formula for methods 1 and 2. And none of the values here fail. That's if there was a failure of the meeting the threshold, that's a possibility for those. Okay, so next we set weights for each of the sub-factors or requirements that we measure. So notice that the weights here look very similar to the priorities in the slide that showed priorities. There were 4, 3, 2, and 1 starting from the top. And here we have 0.4, 0.3, 0.2, 0.1. Notice that the sum of weights here add to 1. That's going to be consistent in in multiple options we talk about. So this particular weighted decision matrix uses something called rank to linear weight. Let's talk about formulas some more. Okay, so we use priorities to create weights. That can be done directly, manually, or using formulas. There are many, many options for formulas. You should select a formula that fits your stakeholder prioritization analyses. So you should consider, are there unusually big jumps in importance for any neighboring priority items? Or are differences in priority importance evenly distributed? Do your stakeholders really want to focus on those high priority items, really strongly and much more than the other ones? Those considerations from your stakeholders, they affect the formula you should use. So one option is rank to linear weight. Weights are always larger for higher priorities, and the differences in this case are relatively constant between consecutive weights. So in this chart to the right, you see priority versus weight for 20 priorities. That's the x-axis, and the weights are the y-axis. And there's just a nice even line. And the formula is given here in a blog post we're going to be publishing soon. We provide formulas that in a version that can be easily copy pasted into your spreadsheet of choice. Okay, so back to our example using our weights. The scaled test results are multiplied by the weights to derive these weighted results per method. They're added together in those rightmost 2 columns at the bottom. And method 1 has the highest score because it matches stakeholder quality objectives best. So automation wins. So another formula that we could have used for weighting instead, and that seems like it's useful in many stakeholder scenarios, is linear with local step multipliers. So the idea is that the weights, differences between consecutive weights are mostly constant and larger only at specific jump points. So in the chart that you see, in the graph you see to the right, priority again is x-axis, weights y-axis, and you see that there are 3 jump points. I put little red arrows to highlight the jump points. The leftmost one is real small. It's kind of hard to see just with to see. The next because the steps are the jumps are weighted 1.5 from the left, then 3 for the next red arrow, and 8 for the rightmost arrow. So you can see that the magnitude of the jump is is bigger, if the jump factor is bigger. So there's a nice formula that looks really complicated right there. But we, in the blog post, provide Excel. We provide something that can be put into a spreadsheet for it. And there's your second option. So the third option we want to talk about is this rank reciprocal method, where there's this steeper drop off for medium and lower priority weights. And you can see with the priorities on the x-axis again, you can see towards the right, there's a big jump. The higher priority items are weighted much higher. So back to a little bit of discussion of Silent Sentinel. Silent Sentinel helps you to fill out metrics in the weighted decision matrix. And very nicely, it integrates into DevSecOps and CI/CD environments as it's built with containers to allow easy orchestration. So today we have talked about how to address the problem of poorly defined requirements in software system design and strategies to help define good requirements, including analyzing requirement trade-offs, lean into modern software engineering practices, using math to validate and support your decisions, and we've discussed some tools and techniques you can use with them. Thank you so much for your interest in our webcast and for your interesting questions. We invite you all to check out the linked resources listed on this slide and also in the YouTube video notes. The slides will be downloadable soon, and we also have this SEI blog post coming out soon about all this that will provide more detail in some aspects. We're interested in improving software quality by creating software that's secure by design, improving software engineering processes. And we invite you to contact us about that.
So quick question from one of our colleagues, Mike Bandor, had asked Lori, what was the rationale for using an inverted prioritization scale? He's just curious.
We just wanted to keep the higher weights pointing towards what we were looking for. So it was, it just worked with our brains, I guess, that way. So good question, because as noted on those previous slides, we did invert the classical formulas.
A question we got earlier from Sarik Kumar asking, what are the early warning signs or symptoms of poorly defined requirements? How can these be spotted?
Yeah, that's a great question. I think one place where you can spot problems early is during that planning phase when you are comparing the utility tree created by your architects and the scenarios that have been brainstormed by all of your stakeholders. If there's massive disagreement there, you may have some big perception problems on what is the purpose of this software, what requirements does the software need to have. That would indicate a very early problem in the earliest of design and planning phases. Some other things that could indicate problems are if generally, even after you've done some planning, you felt confident your initial set of requirements was pretty correct, but you find that you end up building the wrong thing and your stakeholders aren't interested in using it, or it doesn't work the way they intended. That might indicate there was a problem with your requirements. If you are, again, we're leaning into the DevSecOps mindset. We're constantly looking for feedback. We always want to be engaged with our feedback loop to hear from our stakeholders in all phases of our software development process to find out, hey, that software we delivered to you last week, how's that working for you? Is it doing what you need? Are there any problems that we need to address? And being able to take that feedback and iterate with it and constantly be adapting to the requirements that might be changing. Maybe you've learned something now that your stakeholders are using the software. They say, hey, we thought we wanted this, but it turns out our workflow works much better if we go this other way. You take that information back to your software development team, you integrate that into the adjustment of your requirements, and you adapt to things as they've changed. I think another way to tell if your requirements aren't as good as you had hoped is the development of a particular feature taking much longer than you anticipated. Maybe there was some issue with your requirement that's indicating a problem with getting that feature out the door. I think if there's misalignment in the perception of priorities between various groups too, that can indicate a problem with your requirements.
Great. Maybe two quick more if we can. I don't know if they're in your real house or not, but I saw measurements. So one I'm going to address to you, Lori, see if you're familiar with this one. But Lonnie had asked, I usually use cosmic function points to measure functional size. Is there a standard measure for quality attributes? Is that in your wheelhouse? The answer.
I'm sorry that I'm not familiar with Cosmic,
Yeah.
and I think for every quality attribute there are many different tools. Which kind of brings us back to that LLM possible utility that helps brainstorming in addition to your team's expertise. So sorry, Lonnie.
And last one, maybe for you, Lyndsi, if you could answer this one. We got one that asked, Agile development prefers user stories, etc. Can you please compare and contrast these two traditional requirements?
I think I would answer this question by saying both requirements and user stories are going to be necessary pieces, or at least those ideas are going to be necessary pieces, whether or not you actually use the term requirement and user story in your development process. They're necessary to understanding and planning your software. I think when you're talking about the differences, a requirement is going to specify what the software is supposed to do. When you get into the idea of writing a user story, I think you're simply trying to describe that requirement in a way that's actionable for your development team, right? You're thinking from the user perspective, like as a user of this software, I want the software to be able to do X so that Y. I would say that's a way to help build a framework around describing a requirement. But at the end of the day, your user stories, right, as you're building software, again, leaning into these DevSecOps principles, we're going to be using DevSecOps tools like code repositories, issue trackers. We want to be able to take the issues in our issue tracker and in some way map those back to our requirements so that we do have an understanding of how the issues that our users are encountering or that our software developers are developing, how should those be prioritized, and what's the correct way to implement them.
Great, thank you for that, Lyndsi. Lori, Lyndsi, great discussion today. Thank you very much for sharing your expertise. We appreciate you guys being here. And last but not least, we'd like to thank you all for attending today. Upon exiting, please hit the like button below the video window and share the archive if you found value. Also, you can subscribe to our YouTube channel by clicking on the SEI seal in the lower right corner of the video window. And as we mentioned earlier, any questions from today's event, you can send to info@sei.cmu.edu. Thanks, everyone. Have a great day.